All right. Hi, guys. So my name is Max. I'm one of the SIs for Dr. Maduro's 5A class. And in this video, I'm just going to be going over like a dihybrid cross, at least in this case, a cross where you're seeing two different genes. And in our case here, we're going to be looking at two genes A and B, and kind of just like what are the typical things you might see out of them. Um, and I guess like in the steps that I would take or the steps that you guys might want to take in terms of approaching problems like this. So I'll go ahead and get started. So for questions like this, the first thing you want to do is determine the gametes. If you try to do a cross like this, where we did a normal, I would say like a monohybrid cross, like you guys know how to do. For example, like if we were to do, if we had a monohybrid cross, right? You'd have, let's say, big A, big A, little a again here, right? We'd cross those, and you end up with four different genotypes, right? We get big A here. However, if we did this for the dihybrid cross, it wouldn't work, right? Because we're not just looking at one gene, we're looking at two. Okay, so if I did the same thing, if I expanded it, where I did like a whole, and I'm not gonna do this one, I'm just gonna show you guys. If I did a whole thing here where I just crossed big A, big B, little b, and then on this side, let's say I have big A, big B, sorry, small b, small b, small b. The issue here would be like, okay, I can cross these guys, right? And this will look like this part here. Oops. Everything in here is going to look like this, right? And we know that. However, if I was to cross them, I'm missing that B gene, and that doesn't work in this case, right? I need to have that B gene, especially since I have these two alleles that are related in some sense, right? And so I'm gonna erase this. All right, so for gametes, a way that you can think about this is like how I like to think of it is like a FOIL method almost. So if I take our first one, if we have A, big B, little b, right? The way I like to do it is I go from the beginning and then I move over. So you have to always get one from each kind of letter. So in this case, I'd start at big A. I would make that one. So the first one there would be AB, or big A, big B. And then I would go from the big A to the little b, and you would get big A, little b. Okay, so now we're done with the A's. Now if we move on to the little a, if we go little a to big B, that works too. And then if we go big A to little b, we have those, right? And so those would be the gametes for our dihybrid right here. Okay, so we have big A, big B, big A, little b, small a, big B, small a, small b. Okay, so we can do the exact same thing for this other guy over here in a very similar fashion. However, you'll see that this one doesn't take as much time just because you can see that the B's are pretty much the same. So what I mean by that is if I did the same cross, I would find like, okay, I get big A, little b. However, if I did this one too, I would get the same thing. So there's no point in me writing it again. So for now, the gametes that I can get would be this big A and little b. If I was to do the same thing for this side, I would see, okay, I get a small a, small b. However, if I repeated this, right, did the exact same thing, I get the same gametes. So and on that note, like these two would be the only gametes and I wouldn't get four, right? And you can see that because of the homozygous nature of the B allele, okay? And so questions that you might get about the gametes specifically, I'm going to do those kind of off to the right-hand side here. There might be questions you'll get, you might get questions like, you know, what proportion of the gametes are a certain thing, what proportion of the gametes are homozygous, heterozygous, right? And so if I'm looking at the gametes of this one on the left, I know that I have AB, 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 and they're all AB, and then lastly, of course, you have AB, right? And so if I was to ask you guys, like, what are the different gametes, and I guess you would be able to generate this table, right? And rightfully so. However, if I was to ask you, like, okay, what proportion of the gametes are homozygous, right? So meaning, or which ones are completely dominant, you would know, like, okay, so let's look at that. If I was asking for which one is completely dominant, I'm gonna write that up here. Proportion, right? You can kind of check this off of the list. So this first one is completely dominant. The second one is not, right? Because the small b. This one is also not. And this one, while it is homozygous recessive, it doesn't work either. So that makes us 1. And then if we're looking at the proportion, it's out of the total, and that would be out of 4, right? And so, you know, those are questions that you might get. So make sure you keep a lookout for those. All right. So if I was to do my cross now, I would first want to set it up, and then I want to actually perform it. And so what I'm going to do is I'm going to set up a table so I can just fill it in, and that might be easier for everybody. So I'm going to set up a table. Oops. And okay, so our table here, I'm going to need 4 columns or 4 rows and 2 columns or 2 rows, right? And so it's not, again, it's not too big of a deal, whichever way you want to make it. I'm just going to make it 3, that way kind of we're good there. Okay, and so if I was to perform this cross, you would be able to see that, I'm just going to fix this over here. You would be able to see that I would put, you know, the alleles of one, I guess you can say one genotype on one side and the alleles of another on the other side. So it doesn't matter where you put them. So I'm just going to put AB up there. And so this top side is the right allele, and the left side will be our left allele, sorry. And I like to arrange them however you want to. Geez. And like something. And then, okay, let me center it. Okay, that's better. All right. So for a question like this, if we're crossing them, you want to get the 2 A's together and you want to get the 2 B's together. Okay, so if I'm crossing them, think of this as like another multiplication thing, right? Like, or addition, I guess might be better. So if I have 2 A's, I'm going to put my 2 A's there, and then I have a big B and then a little b. On this side, I have a big A, big B, little b. On this side, I have 2 big A's and then 2 small b's. On this side, I have a big A, little a, and 2 small b's. And this side, again, a, big B, little b. My goodness, why is this not letting me do it? And then I'm just going to fill this out. Okay, and so at the end of this, we have our I guess this was the setup, and we performed the cross. right? And so we know that these are our different genotypes. And so if I told you, like, given these phenotypes, which ones, or what's the proportion of the phenotypes that, I'm just going to randomly pick one. Hang on, let's type it over here. Proportion of phenotypes that are, let's say, blue and smooth. Okay, so what is that telling me? This is telling me that we need to look for anything that has, or any genotype that is dominant for A and recessive for B. Okay, and so anything that has, and I guess for this, in this case, we have to remember that recessive for B means that we need to be homozygous, right? If I have a recessive B allele, it gets overpowered by that dominant B allele. Okay, and so let's look at those. So I'm going to underline all the ones that fall into this category. So anything that's dominant A and recessive B, right? So if I look through them, this one is dominant A, recessive B. This one would be dominant A, recessive B. This one too, and that would be it, right? So our proportion here, we get 3 of them there. Okay, and then the total that we have is 8, and so our answer here would be 3 out of 8. Okay, so that's just a typical question you might get, and that's kind of, that builds into our ratios and phenotypes question down here. So let me just put this better in frame. So what I like to do is I'm just gonna copy and paste it. There we go. Okay, so what I like to do in this case would be, you could literally just write, like, excuse me, you could write down the different phenotypes in here. So this one would be blue spiky, and you could do this for literally all of them. This one would be also blue spiky, and so on, right? This would be blue smooth, this one blue smooth, and if you kept doing this, you'll end up getting some red ones like this one. This would be red spiky, this would be red smooth, and let me just finish this out, might as well. Blue spiky, and then lastly we have blue smooth. Okay, and so that also tells you, it's a easier way to kind of depict the different phenotypes and the ratios we have between them. So that's something you could definitely do. And lastly, let me just go over, like, another question that you might get would be, I guess, what proportion of the phenotypes are parental? Okay, and so, or sorry, genotypes. In essence, I could definitely ask you for the phenotypes that are parental, and that would mean, and what this parental means is just saying, like, what genotypes or phenotypes are the same as the parents, right? So in this case, we know this first one would be blue and spiky, and this one on the right would be blue and smooth, right? And so anything that has the same phenotype as that would be considered parental, and then we could get the ratio that way, right? And so for this one, if I'm looking at genotypes, anything that has a heterozygous A, heterozygous B would be parental. Anything that's heterozygous A and homozygous B, however, homozygous recessive B, would be parental also, right? And so we can underline that. Let me change the color. So I would get one over here, one over here, one over here, and one over here, right? So this one, this gives us 4 out of 8 or 1/2. That's not necessarily the case all the time. Just so happens we got 1/2, right? So just make sure that we get all of our answer choices correct. So if you have any other questions, go ahead and talk to your SI. I will be more than happy to go over these types of questions with you in office hours and during our sessions. And yeah, have a good day.